You already know that paper is not a cutting instrument. Not technically, not in the way a blade is a cutting instrument. A blade is engineered to separate tissue, ground to an angle, honed to a geometry designed around the physics of division. Every choice in a knife's construction is oriented toward one outcome: clean, predictable separation of material. Paper was designed to hold words. The fact that it can open your skin at all is almost an accident, except that when you look closely at the physics of how it does it, the word accident stops fitting. The physics of a paper cut is not incidental to the paper's existence. It is specific. It is in several measurable ways that I did not anticipate when I started looking into this, meaner than the physics of a knife wound at the same depth. Not more dramatic, not more dangerous, not more medically significant, meaner, more deliberate, in the way that a thing without intention can nonetheless appear deliberate when the outcome is so consistently and precisely unpleasant. And the reason it is meaner has nothing to do with the paper itself and everything to do with what your nervous system does in the first 3 milliseconds after contact. A sequence of events the body initiates automatically, cannot interrupt, and cannot reverse once it has begun, and which explains something I kept coming back to for much longer than I expected to, which is why the same injury feels entirely different depending on where on your hand it happens. The answer to that particular question is not what I assumed it would be when I started. It is stranger, and it points somewhere that the literature on pain science has not fully followed yet, which is the part I want to be careful about, because careful is the only honest way to approach it. I came across this while trying to understand something else entirely. I was reading about mechanoreceptors, the sensory cells that live in your skin and report on the world's texture. The particular give of a surface under your fingertip, the difference between cotton and linen when your eyes are closed, the way a wet surface feels different from a dry one even when the temperature is identical. I was chasing a question about why certain fabrics feel genuinely unbearable to some people, despite being objectively soft by every measurable standard. And I made one wrong turn into the literature on nociception. And then I was 3 hours in, and the original question was sitting open in another tab that I never went back to. Nociception. I want to hold that word for a moment before I explain it, because the word itself is doing something. For the first hour of reading, I had been calling the subject pain in my head. Then I found out that nociception and pain are not the same thing, and the distinction is not the kind of pedantry that researchers use to feel precise. It is the entire point. Pain is the conscious experience, the thing you feel, the thing you report, the thing that makes you pull your hand away and use language that is not suitable for all audiences. Nociception is the signal, the electrochemical event that travels from the site of something happening in your tissue toward the brain that will ultimately decide what to make of it. The signal can happen without the experience registering at any conscious level. The experience can arrive vividly and urgently without a clear nociceptive signal to justify its intensity. They are related the way a fire alarm is related to a fire, connected, consequential to each other, causally linked in the usual case, but not the same thing, and the gap between them, the space where the signal becomes or fails to become experience, is exactly where paper cuts live. What I thought I knew when I started was the version that most people know, the version that gets taught in introductory biology, repeated in science communication, and stated with the kind of confidence that accumulates around things that are mostly right. Small cuts hurt more than large ones because there are more nerve endings close to the surface of the skin. The fingertips in particular are densely innervated, more nerve endings per square centimeter than almost anywhere else on the body. More nerve endings means more signal. More signal means more pain. The fingertip paper cut is the worst paper cut because the fingertip has the most nerve endings to disturb. This is not wrong. I want to be fair to it because it is genuinely true as far as it goes, and it goes a reasonable distance. It is the kind of true that sits just above the interesting part, and from where it sits blocks the view. It answers the question you came in with. It does not answer the question that appears once you stop looking at the tissue around the wound and start looking at the physics of the wound itself. The geometry of how paper enters skin, what that geometry does to the signal before the signal has even left the wound site, and why the overlap between different classes of nerve fiber might produce something the brain genuinely does not have a template for. What stopped me specifically was a paper on wound edge geometry that I found while looking for something else. It described the microscopic structure of a paper cut in terms that made the injury sound less like an accident and more like a precise provocation. I kept rereading the section on signal overlap. I kept thinking, if this is what is happening, then the standard account is not just incomplete. It is describing the wrong thing. I am still not sure I have resolved this. I have gotten closer to understanding it. But closer to a hard question is not the same as close. And I think it is worth saying that clearly before I show you what I found, because some of what I found is settled science and some of it is at the edge of what the current literature can support. And the difference matters. I make these videos because I keep following problems like this into rooms they weren't supposed to be in. If that sounds like your kind of difficulty, you know what to do. Here is the shape of what I want to show you before I show it. First, the standard account. Why small cuts hurt more than large ones. I want to state it fairly and in full, not because I am going to defend it, but because you need to know what it actually says before you can see where it stops being sufficient. The standard account is not a straw man. It is a real explanation that does real explanatory work up to a specific point. Second, the physics of the wound geometry itself, not the tissue response, not the nerve endings, not the inflammation, the geometry. The way a paper edge moves through skin is categorically different from the way a blade moves through skin. And that categorical difference changes the character of what the nervous system receives before it has time to process anything consciously. This is where the standard account runs out of road. Third, an implication that almost nobody discusses in the public literature on pain. Not because anyone is concealing it, but because it requires sitting with an answer that does not feel like an answer. It feels like the first sentence of a harder question. That is where I want to take this, and that is where I want to be most careful. One thing worth naming about this structure before I move through it, the second layer, the wound geometry, is not quite a cause in the way the first and third layers involve causes. I included it not because it drives the outcome the way a mechanism drives an outcome, but because its absence from most public explanations is itself a kind of signal. When a field consistently stops explaining something at a particular point, that stopping place is interesting. The gap is informative. The question of why the standard account does not mention wound edge geometry is almost as interesting as the geometry itself. Paper has an edge, that is obvious, but the geometry of that edge is not what you picture when you picture it. And the difference between what you picture and what is actually there is where everything about the paper cut's cruelty begins. When you picture a paper edge, you probably picture something like a knife edge. Thinner, yes. More flexible, but fundamentally the same kind of thing. A line, a clean boundary between one surface and another. This picture is wrong in a way that matters enormously to what happens when that edge contacts your skin. A steel knife blade, even an inexpensive one that has never been properly sharpened, is ground to an angle. The edge is a wedge. It has a geometry that was put there deliberately. When it contacts tissue, it works by displacement, pushing the material it encounters outward and downward as it advances, creating a stress gradient ahead of the actual point of separation. The tissue experiences something approaching preparation time. Not much, we're talking about microseconds, but the wedge geometry means the force is distributed across a predictable shape. And the nervous system receives a signal that the brain has a category for. Sharp mechanical intrusion. The A delta fibers activate the fast-thin myelinated nerve fibers responsible for the immediate, acute, first hit component of pain. And the brain processes this as a known type of event. Something sharp has entered, the response is calibrated and appropriate. Paper does not do this. Paper cannot do this because paper's edge was not made to cut. A paper edge, examined under a scanning electron microscope, is not a line, it is a row of irregular microscopic projections. Serrations at the scale of 50 to 200 micrometers, each one slightly different in height and angle and sharpness from the ones adjacent to it. The variation is not random noise. It reflects the fibrous structure of the paper itself, the way cellulose fibers were pressed and bonded and dried and then sheared during manufacture. Each cut sheet of paper has a slightly different edge because each shearing event through the fibrous matrix produces a slightly different microscopic result. When this edge contacts skin. It does not push tissue aside in a wedge pattern. The microscopic projections catch on the surface. They create multiple simultaneous points of concentrated mechanical stress, each one at a slightly different location and angle, each one pulling and compressing adjacent tissue in a slightly different direction. And then, at the moment the force concentrated at any one of those stress points exceeds the tensile strength of the skin, the tissue fails. Not cuts, tears. I need to correct something I just implied because the distinction is going to matter. I said paper tears the skin, which is accurate at the microscopic scale. But what you observe at the macroscopic scale, what you see when you look at a paper cut, looks indistinguishable from a clean cut. It looks like a knife wound. It is not. At the cellular level, the wound edges are irregular in a specific way that a blade wound is not. They are frayed. And that fraying changes the local wound environment in a way that changes the signal before the signal has left the site. This is where the standard account, more nerve endings, more signal, more pain, starts to become insufficient. Because the story is not just about how many nerve endings are present. It is about what those nerve endings receive and what happens when what they receive cannot be processed by the brain's existing templates. The fluid that floods a wound in the first seconds after injury is a complex mixture. Inflammatory mediators, sensitizing chemicals, substances that lower the activation threshold of nearby receptors, signaling molecules that communicate the event to the immune system. This fluid interacts with the wound edges. Irregular, frayed edges present more surface area than clean-cut edges. More surface area means more contact between the inflammatory environment and the nerve endings embedded in the surrounding tissue. More contact. And the sustained kind of contact that follows irregular geometry rather than resolving cleanly means a lower threshold for subsequent signals. The wound environment is not just the site of damage, it is a variable that shapes every signal that follows. You, specifically, based on what you now know about the difference between nociception and pain, and about why signal character matters as much as signal volume, can see why this starts to become a different problem than the one the standard account was solving. There is a researcher named Matthias Ringkamp at Johns Hopkins who has spent years producing some of the most detailed maps available of the nerve fiber. Classes involved in different categories of pain. He is, by the account of several people who know him and his work, a mediocre chess player, which I mention not because it is relevant to the science, but because it is the kind of detail that makes a person real rather than authoritative. And I find his work easier to sit with when he is real. He identified with a precision that took years of careful experimental design to achieve that the fiber classes activated by sharp mechanical damage, the kind a knife produces, are distinct from the fiber classes activated by sustained tissue distortion, the kind of prolonged low-grade multidirectional stress that a wound with irregular edges in an inflamed environment generates over time. What his findings imply for a paper cut is this. The wound activates both classes of fiber, not sequentially the way the brain expects, simultaneously. The brain receives two overlapping signal types that would, under ordinary circumstances, arrive in order. The fast, sharp, a delta signal first, indicating acute mechanical damage, then the slower C fiber signal as the wound environment develops over minutes and hours, indicating sustained tissue distress. When they arrive together, the brain cannot process them with its standard template. It receives a signal combination that does not match any category in its existing library of known events. And the brain's response to a signal it cannot categorize is consistent, well documented, and in this context, extremely inconvenient. It amplifies not because the damage is severe, because the pattern is unusual. The amplification is not an error or a malfunction. It is the system operating correctly under conditions it was not optimized for, treating the unfamiliar as a threat level indicator and responding accordingly. Now add one more variable. And this is the one that connects to the question I mentioned at the beginning about why location on the hand matters so specifically. The areas where paper cuts are reliably worst, the fingertips, the webbing between the fingers, the skin over the proximal knuckles, are the areas with the highest concentration of a receptor class called Meissner corpuscles. These are not pain receptors in any conventional sense. They are exquisitely sensitive mechanoreceptors tuned to detect fine texture, light touch, the slight differential resistance of surfaces at a very fine spatial scale. They are what allow you to distinguish a raised letter from a flat one by touch alone, to feel the edge of a key in your pocket without looking, to know whether a surface is powdery or silky without being able to name the difference. They have no ordinary role in nociception. They were not designed in the evolutionary sense to participate in the pain signal. But paper's dragging, multi-point, serrated contact across the skin surface stimulates Meissner corpuscles along with everything else. The brain now holds three simultaneous inputs: the sharp mechanical signal from A delta fibers, the sustained distortion signal developing from the wound environment, and the fine texture signal from Meissner corpuscles firing in a context where fine texture is emphatically not what is happening. Three signals, none of them individually unusual. Their combination without precedent in the brain's library. The amplification that was already underway intensifies further. And then the cut announces itself late. You notice it when the soap reaches it, when the lemon juice finds the edge, when the paper is already across the room and several minutes have passed and you look down and understand what happened. The fast fibers fired in the first milliseconds. The Meissner corpuscles fired. But the C fibers, unmyelinated, slow conducting, responsible for the dull, persistent burn rather than the sharp initial spike. They arrive last. And they arrive into a nervous system that has already been amplifying an unusual signal for minutes. The C fiber input does not create the intensity you feel. It inherits it. it lands in a system already running hotter than the damage warrants. And the system has no mechanism to immediately correct this. Because the correction process for signal amplification is slower than the amplification itself, this is what the standard account is circling without quite reaching. The density of nerve endings matters, but it is not the whole mechanism. The whole mechanism is about what those nerve endings are doing simultaneously, what the brain does when it cannot reconcile their outputs, and what state the nervous system is in by the time the slowest signal arrives. You are probably expecting this to start resolving. I was expecting the same thing at about this point in the research. The mechanism seemed coherent. The amplification explained the intensity. The delayed onset explained why the cut announces itself only when something irritating finds it. The Meissner corpuscle involvement explained why the fingertip is worse than the forearm. There was a story here, and it was a complete one. Then I found the 30%. In the literature on cutaneous pain profiles, the specific pattern of intensity over time that different wound types produce, measured through standardized self-report scales in controlled conditions, roughly 70% of paper cut cases follow a predictable trajectory. Delayed onset, escalating intensity, peak within 30 to 90 minutes, gradual resolution over several hours, return to baseline well before the tissue has healed. The mechanism I just described predicts this profile. The mechanism explains it clearly. The other 30% have a different profile. The peak arrives earlier, the resolution is slower, and in a significant subset of those cases, there is a secondary intensification, a second wave of heightened sensitivity that arrives after the first has begun to fade hours later, without any apparent change in the wound environment that the standard model would predict should matter. 30% is not a rounding error. It is not measurement noise. It is too large and too consistently shaped to be explained by variation in pain tolerance or differences in reporting behavior. The profile it describes, early peak, slow decay, secondary wave, suggests something that I want to be careful about stating. Because I am genuinely at the edge of what I can claim here with confidence. The possibility that the nervous system's response to an unusual signal combination does not return to baseline along the same path it departed from it. That the amplification, in some cases, leaves something behind, not damage, not anything clinical. A calibration, a small, potentially persistent revision in the parameters the nervous system uses to process the next ambiguous or unusual signal it encounters. If this is real, and I am not certain it is, and the literature is not certain either, then a paper cut is not purely an event. It is, in some measurable but not yet fully measured sense, an update. And this is what I have been circling the entire time. The thing that appeared first as a footnote and then refused to remain one. The question of whether the nervous system's response to pain is purely reactive, signal in, experience out, return to baseline, or whether it is in some meaningful sense, cumulative. Whether the system that processed your last unusual signal combination is strictly identical to the system that will process the next one. Whether the calibration, if it exists, accumulates. Whether it is reversible. Whether you are in ways that are real but not yet fully characterized, different after each one. Nobody has answered that. Not in a way that settles it. Not yet. So I am back where I started, more or less. That edge, the ragged, toothed, 50 to 200 micrometer edge that was never designed to cut anything and cuts you anyway, that tears rather than divides, that drags Meissner corpuscles into a process they were not built for. That sends the brain a signal combination it has no template for and watches the brain respond by turning everything up. I understand it better now in the ways that can be made precise. The geometry is documented. The simultaneous multi-fiber activation is measurable. The amplification mechanism is real and understood well enough to explain why the injury is meaner than its depth warrants. The 70% makes sense. The 30% is still there. Still shaped the way it is, still pointing at something the framework around it was not designed to see. Behind the 30% is a question that has the structure of a simple question and has resisted simple answers for longer than it should have. And I think this is the honest version of where I am. I think it resists them because we keep approaching it from inside a model that treats the nervous system as a reporter. A system that receives events, produces experiences, and resets. The 30% behaves as though the reset is incomplete, as though something is retained, not a memory in any meaningful psychological sense. Something more like a posture, a slight, durable adjustment in how the system leans toward the next ambiguous input. If that is what is happening, the paper cut is not just meaner than the knife wound in the moment. It is doing something the knife wound does not do at all. Something that might not stop when the cut does. I think that is the honest place to stop for now.